is on trigonometry. So today we're just going to focus on something called right triangle trig. We're going to focus on the basic trig ratios, using those ratios, and then using those ratios to find side lengths of right triangles. So a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. And the three trigonometric ratios that we're going to talk about are sine, spelled S-I-N-E, cosine, and tangent. Okay, so to find a trig ratio, we need to use one acute angle, which is going to be called the reference angle. All right. And when you have a reference angle, so we're going to start with A here, this angle A as one of our reference angles. All right, I'm going to call that theta. That's a Greek letter, theta, that we typically use when we're talking about angles. When we are trying to find these ratios, all right, we give three different names to the sides of a right triangle. Okay, so the first one is a hypotenuse. So a hypotenuse is the longest side of a right triangle. It's always going to be the side that's across from your right angle. Okay, so the hypotenuse is nothing new. The next two sides are going to be determined on what your reference angle is. Okay, so our other two sides are called the opposite and the adjacent side. So if this angle A is my reference angle, then this side here that I called A, lowercase a, is going to be your opposite side because it's opposite from that from that reference angle. Your other side is going to be the adjacent side. Okay, so adjacent means next to. All right, so in every angle in your triangle, all right, you have two adjacent sides. If you're looking at one of the two acute angles, which we always are going to be looking at when we're dealing with trig, one of your adjacent sides is going to be the hypotenuse, but that's your hypotenuse. We always label the hypotenuse as the hypotenuse. And then the other side that's next to your angle is your adjacent side, okay? So your sine ratio, we use S-I-N for short, is going to be the ratio of your opposite side over the hypotenuse, okay? The cosine, which we use C-O-S as the abbreviation, is going to be your adjacent side over your hypotenuse. And then a tangent, we use T-A-N, is for abbreviation, is going to be your opposite side over the adjacent side. Okay? And the way that we can remember that is using this acronym SOHCAHTOA. All right, so if you ever heard of SOHCAHTOA, this is what it stands for. Sine is your opposite over hypotenuse. Cosine is your adjacent over hypotenuse, and tangent is your opposite over adjacent. Okay? So let's just practice identifying these ratios. All right, so if I was looking at the sine of A, that's going to be your opposite side over your hypotenuse, which would be A over C in this case. I'm just going to use the variables here because I don't have numeric lengths. Cosine of A is your adjacent over hypotenuse, or B over C. And then the tangent of A is going to be your opposite over your adjacent, or A over B. Now, that was all with my reference angle of A. My other reference angle could be angle B. So if I change this reference angle to angle B, All right, I'm going to put my little theta there so I know that's my reference angle. Okay, my hypotenuse is going to stay the same because your hypotenuse is always opposite your right angle. That doesn't change when you change your reference angle. But the opposite and adjacent sides are going to change because now this side B is opposite your angle B. And this side A is your adjacent side to reference angle B. Right? So it's important when you name your reference angle, I usually like to circle it, and then I label my sides as my opposite, adjacent, and hypotenuse. Okay? So the sine of angle B is going to be my opposite over hypotenuse, which is now B over C. The cosine of angle B is going to be your adjacent over your hypotenuse, which is A over C. And then the tangent of angle B is your opposite over adjacent, which is B over A. Okay? So now let's practice doing this with right triangles that have the side lengths in. Okay? So for number 1, all right, I want to find the sine, cosine, tangent of angle A, the sine, cosine, tangent of angle B. So I'm going to do angle A first, okay? So angle A is going to be my reference angle, and I'm going to label my opposite, my adjacent, and my hypotenuse. So my hypotenuse is usually the easiest place to start. That's my side that's across from my right angle, so I'm just going to put an H there, all right? Your other adjacent side is going to be your A, and then the side across from that angle is your opposite, so I'm going to put an O there, okay? So going back to SOHCAHTOA, sine is your opposite over your hypotenuse. So because I have these already labeled, right, I just have to go in my diagram. O over H is 9 over 41. Cosine of A is adjacent over hypotenuse, A over H, which is 40 over 41. And then the tangent of A is your opposite over adjacent, 9 over 40. Okay? Now, if I want my reference angle to be angle B, all right, I'm going to circle angle B here. Your hypotenuse stays the same, but now this opposite side becomes my adjacent, and this adjacent side becomes my opposite side, all right? And if you're using a pencil, I like to erase those so I don't get confused, okay? So now the sine of angle B, again, that's my opposite over adjacent, which is now 40 over 41. The cosine of angle B is going to be my adjacent over hypotenuse, or 9 over 41. And then my tangent is my opposite over adjacent. Opposite over adjacent is 40 over 9. Okay? So let's do one more example, and then we're going to look at some key takeaways, any important patterns that we might have noticed. Okay, so for number 2, here my reference angle that I'm going to start with is R. So again, I'm going to label my hypotenuse first. All right, my adjacent side is the other side that's next to my reference angle after I've labeled my hypotenuse. And then that side across from or opposite angle R is your opposite side. Okay, so the sine of R, opposite over hypotenuse, is 21 over 29. Cosine is adjacent over hypotenuse, 20 over 29. And the tangent of angle R, your opposite over adjacent, 21 over 20. Okay? Now, once I switch that reference angle, okay, my hypotenuse stays the same, right? But now this side here, side ST, that's 21, is going to be my adjacent. All right, and over here, that's my opposite. Okay, so I'm going to erase those again. All right, so the sine of angle S, opposite over hypotenuse, is 20 over 29. Cosine of angle S is going to be 21 over 29. And the tangent of angle S is going to be 20 over 21. Okay? So let's see if we notice any patterns, or I'm calling these key takeaways because these are some really important concepts that you want to know. They come across on a lot of standardized testing like the SAT or whatever your state testing is. So the first one says, what relationship do you notice between the sine and cosine ratios? So you might have noticed a pattern when we were dealing with the variables and when we were dealing with numbers. But if I take a look here at the sine of angle A, that was 9/41. That was the same of my cosine of angle B. That was also 9/41. Okay. The sine of R was 21/29, which was also the cosine of S. All right, I noticed that also happened. All right, so here the cosine of A was 40/41, which was the same of my sine of B, which was 40/41. This cosine of angle R was 20/29, which was the same as my sine of S, which was 20/29, okay? If we look at the variables, we see that it is always going to happen. So the sine of A here is A/C, which also is the cosine of B. And the sine of A was B/C. I'm sorry, the cosine of A was B/C, which was the same as the sine of B, B/C. Okay, so what we can say here is the sine of A equals the sine, the sine of A equals the cosine of B. All right. And the sine of B equaled the cosine of A when, all right, we want to say A and B are complementary angles. Okay, so if you have two angles, right, so angles A and B are complements of each other, all right, the sine of A is going to be equal to the cosine of B. All right, sometimes we see that written as the sine of X equals the cosine of 90 minus X, okay, because this right here tells us that those angles are complements of each other. All right, that's a good pattern that you want to recognize. It's something, like I said, that comes up on a lot of standardized tests like the ACT and the SAT. Okay, and then the next question says, what is the ratio, or which ratio is the only one that is greater than 1? Okay, so if I looked here, all of these ratios, if I plugged them into my calculator, I would get a decimal less than 1, except for one ratio in each of these triangles. Okay, and that ratio, all right, in this case was tangent of angle B, and in this case was the tangent of angle S. All right, so it's always going to be tangent. All right, tangent is the only ratio that can ever be greater than 1. All right, and that's going to be because, I'm just going to abbreviate here, all right, sine and cosine are always divided by the hypotenuse, okay, which is the greatest side. Okay, so with your sine and your cosine, the hypotenuse is always going to be the longest side of that triangle. So you're always going to be dividing a smaller number by a bigger number, which means it's always going to be less than 1. So tangent is the only ratio that's ever going to be greater than 1, okay? That's something that you want to know. So if you do any of these problems and you happen to get a number, you plug it into the calculator that's greater than 1 for sine or cosine, you know that there was a mistake there, okay? So next we're going to talk about how we can use these ratios to find a side of a triangle. All right, now I don't usually put steps in here, but this is a pretty big topic, so I wanted to make sure we had some steps in here. So the first step for using trig to find sides, all right, is to identify the reference angle and label the sides of the triangle. So the first thing I'm always going to do is highlight or circle the angle that I know. That's going to be the reference angle, and then I'm going to label my sides O, A, and H. Then you're going to determine which trig ratio you're going to use. So based on the side that you're given and the side that you're trying to find, you're going to determine if we're going to use sine, cosine, or tangent. Then you're going to set up the equation. I'm going to show you how to do this as a proportion, and you're going to solve, okay? So let's take a look at number 3. All right, I have a right triangle here, and my reference angle is 27 degrees, okay? So I circle that angle, and then I'm going to label. I have my hypotenuse, my adjacent, and my opposite side, okay? Now, I'm going to remember and rewrite SOHCAHTOA. All right, that little acronym that we used. If I look here, I'm trying to find information about my opposite. I know my hypotenuse, so this adjacent doesn't have anything to do with this problem. So I'm just going to erase it. Okay, so I have an O and an H. If I look here, all right, O and H tells me I'm going to use sine. All right, so the way I'm going to set this up is the sine of 27 degrees. All right, I don't have to say angle A or angle B because I know the measure of that angle is going to equal my opposite over hypotenuse, or x over 26. Now, when I solve these equations, I like to be consistent, all right, and do the same thing every single time. So I'm going to set this up as a proportion, okay? The sine of 27 is just a number, all right? It's a decimal value, okay? So any number I can always write over 1. So if I write it over 1, I see that I have a fraction equal to a fraction, which is just a proportion, and I'm going to solve it by cross multiplying. So 1 times x is x, and then this is 26 times the sine of 27. Okay, so let me see if I can get Desmos in here. All right, and I'm just going to type 26 times the sine of 27. All right, so you just plug that right into your calculator. One thing that's really important to note is when you're using a calculator, it has to be in degree mode, okay? So there's radians and degree modes. You see that you get a different answer depending on the mode that you use. So we want to make sure we are in degree modes because we're measuring our angles in degrees, not in radians, okay? So you plug that into your calculator, and we're going to round to the nearest tenth here. So we have 11.8 as our answer. Okay, so x equals 11.8. All right, let's try number 4. Okay, so number 4, our reference angle is 52 degrees. So I'm going to circle my reference angle, and then I'm going to highlight my opposite, my adjacent, my hypotenuse. So my opposite side is this x here. My adjacent side is 30. All right, my hypotenuse doesn't have a number or a variable, so we're not going to fill anything in there. All right. Now I need to determine which trig ratio I'm going to use. So I have an O and an A. And if I look at my SOHCAHTOA, O and A means I'm going to use tangent. So I'm going to set this up as the tangent of 52 degrees equals my opposite x over my adjacent, which is 30. Okay, and then again, I'm going to do the same thing. I'm going to put the tangent of 52 over 1, and then I can cross multiply. So 1 times x is x, 30 times the tangent of 52. All right, I'm going to write that just like that, and then I can plug it into my calculator. So 30 times the tangent of 52. And here I'm going to get 38.4. Okay, now number 5 is going to look a little bit different. Okay, we're going to start it the same way. So I'm going to circle my reference angle, which is 63. I'm going to label. So I have an opposite side here, and I have a hypotenuse. So if I look at my SOHCAHTOA, I'm going to use sine. So the sine of 63 degrees equals my opposite over my hypotenuse, okay, which is 34 over x. Now, sometimes students get a little bit stressed out because we have x in the denominator. If you set this up as a proportion every single time and you cross multiply, you don't really have to worry about what you're doing with that x in the denominator. So I'm going to cross multiply. 1 times 34 is 34. That equals x times the sine of 63. Okay, now the sine of 63 again is just a decimal value. Okay, it's just a number. So I can divide both sides of this equation by the sine of 63. All right, so when I do that, x equals 34 divided by the sine of 63. All right, again, you're going to plug that right into the calculator. All right, so 34 divided by the sine of 63 is 38.2. All right, this is why I suggest setting it up as a proportion every time. So you don't have to remember if you're multiplying, what you're dividing by. It's the same thing, cross multiply and go from there. Okay, so number 6, our reference angle is 41. We have our hypotenuse and then we have an adjacent here. Okay, so again, I'm going to look at my SOHCAHTOA. All right, this is the first example where I'm given an A and an H, so I'm going to use cosine. So the cosine of 41 degrees is my adjacent, which is x, over my hypotenuse, which is 9. All right, put that cosine of 41 over 1, cross multiply. All right, and then we can plug. I'm not going to show you guys plugging it in all into the calculator every single time. All right, this will be the last one I do this for, but I'm going to take 9 times the cosine of 41, and we get 6.8 here. Okay, let's do the next for a little bit quicker. All right, so number 7. All right, circle your reference angle. This is an 11. It's a little hard to see that that's 2 ones. Okay, so that's my opposite side. That's my adjacent. O and H tells me we're going to use tangent. So the tangent of 38 equals 11 opposite over adjacent x. Okay, put that tangent of 38 over 1, and when we cross multiply, we're going to get 11 equals x times the tangent of 38. Divide both sides by the tangent of 38. And x equals 11 over the tangent of 38, which is going to round to 14.1. Okay, for number 8, our reference angle is the 72. We're given the adjacent and the hypotenuse. So we're going to use the cosine of 72 degrees equals your adjacent over hypotenuse, or x over 31. Set up your proportion. And when you cross multiply, that one's just a nice multiply across, and we get x equals 95.4. Okay, number 9, we have our reference angle is 68 degrees. We have our adjacent, we have our hypotenuse. So I'm going to use cosine of 68 degrees equals my adjacent over hypotenuse. So 4 equals x times the cosine of 68. Divide both sides by the cosine of 68. So x equals 4 divided by the cosine of 68, which is 10.7. Okay. For the last problem, our reference angle is 75 degrees. We're given our opposite and adjacent. So I'm going to use tangent here. So the tangent of 75 degrees equals my opposite over adjacent, or 13 over x. Set this up as a proportion. Cross multiply. And then we're going to divide both sides by the tangent of 75. So x equals 13 divided by the tangent of 75, which equals 3.5. Okay? So that's kind of your basic introduction to trig ratios and using trig ratios to find a missing side of a right triangle. If you have any questions, you can comment below. Thank you so much for watching.